So students, now let's start activity 7.1, binomial theorem on any positive integer n. So our objective for this activity is to construct a Pascal's triangle and to write binomial expansion for positive integral exponent. So students, now let's see the method of construction for the given activity. First, take a drawing board and fix a white chart paper on it. Take some matchsticks and arrange them on a paper. Third, and write the number in each row of sticks So in this way we have arranged the numbers by putting each of the matchsticks and numbering at its every node. So this is our first row, this is our second row, this is our third row, this is fourth, fifth, sixth and seventh row. So in this way we get the triangle of numbers. So in this way, by placing the numbers in the given figure, we get the triangle of numbers. So in this figure, we have arranged our numbers in rows, that is, we have removed the diagram and only placed the numbers as we have placed in our diagram according to the rows, that in first row 1, then in second row 1, 1 and in third row 1, 2, 1. So you can understand how this pattern is proceeding. So first of all 1, the first digit and the last digit should always be 1 and the middle digit, that is, it is the sum of the upper two digits, that is 1 plus 1, 2. Now next row, that is fourth row, it is 1, 3, 3, 1. 1. First and last digit are 1 and the middle digit is sum of the upper two. 1 plus 2, 3. That is 1 plus 2, 3. 2 plus 1, 3 and 1 at the end. Similarly 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4 and 1 at the end. Now in sixth row, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5 and 1 at the end. Then seventh row, 1 and then second digit is 1 plus 5, 6, 5 plus 10, 15, 10 plus 10 is 20, 10 plus 5, 15, 5 plus 1, 6 and at last 1. We can proceed this pattern up to indefinite length. Step 5. Write binomial expansion of a plus b to the power n. Use the numbers given in n plus 1 th row. So students, now let's see the demonstration for the given activity. First, the given pattern of numbers is known as Pascal's triangle. This triangle makes easy to find the coefficient of a binomial expansion. Of given integral exponents. The numbers in the second row gives the coefficient of binomial expansion of x plus y to the power 1, that is x plus y to the power 1 equals to 1x plus 1y. The numbers in the third row one to 1 gives the coefficient of the binomial expansions of x plus y to the power 2, that is x plus y to the power 2 equals to 1x plus 2xy plus 1y. Fourth, the numbers in the fourth row one, 3, 3, 1 gives the coefficient of binomial expansion of x plus y to the power 3. So x plus y to the power 3 is equal to, so 1x cube plus the second digit in fourth row is 3, 3 x square y plus the third digit is 3, so the coefficient becomes 3 x y square plus, now last digit is 1, so coefficient 1 y cube. In this way, we use the Pascal's triangle to find the coefficients of a binomial expression. So students, now let's see the observation for the given activity. First, the total number of terms in each expansion is one more than the exponent. For example, the expansion of a plus b to the power 2 has total 3 terms, whereas the exponent is 2. So you can see the exponent here is 2. To the given binomial expansion, we get total 3 terms, that is 1 more than the exponent, that is 2. Second, the power of x goes on decreasing by 1, whereas the power of y goes on increasing by 1 in successive terms. Such as x plus y whole square. So first term is x square and the next term is its successive terms. So in the next term x goes to the power 1 and y is increased to the power 1. So it becomes x to the power 1 and y to the power 1. Suppose for example it is x plus y to the power 3. So now 1x cube. Now power of x will decrease by 1 and y increase by 1. Coefficient is 3. By our Pascal's triangle, the coefficient is 3 and the value of exponent, that is power of x, decreases by 1, x square, and power of y increases by 1. The next term, coefficient is 3, the power of x decreases by 1 and the power of y increases by 1, that becomes xy square, and the next term, the coefficient is 1 and the x power becomes 0, so x to the power 0 is 1 and y is increased by 1, so it becomes 1y cube. So in the successive terms, this rule applies that power of x goes on decreasing and the power of y goes on increasing. In each of the expansion, the sum of indices of x and y are same and equal to the index of x plus y. For example, x plus y whole cube is equal to x cube plus 3x square y plus 3x y square plus y cube. Here the sum of indices of each term is 3. Fourth, the numbers in the third row are 1, 2, 1, which are the coefficient of binomial expression expansion x plus y whole square equals to 1x square plus 2xy plus 1y square. The numbers in the fourth row are 1, 3, 3, 1, which is the coefficient of binomial expansion of x plus y to the power whole cube equals to 1. First digit of coefficient is 1, so 1x cube plus the next coefficient is 3. Now x power decreases by 1, 3x square, and y increases by 1. Now next coefficient is 3. Now x power decreases by 1, x to the power 1 and y to the power 2. Plus the next coefficient is 1 and x to the power 0 and y to the power 3. The numbers in the fifth row are 1, 4, 6, 4, 1, which are the coefficient of binomial expansion of x plus y to the power 4, which is equal to 1x4 x to the power 4 plus the next coefficient is 4x cube y plus 6, coefficient of y decreases by 1, 6x square y square plus 4x y cube plus 1 y to the power 4. So this is the coefficient 1, 4, 6, 4, 1 represents the binomial expansion x plus y to the power 4 and its coefficient 1 x to the power 4, 1, 4 coefficient of x cube y, 6 coefficient of x square y square, 4 coefficient of x y cube and 1 coefficient of y to the power 4. So the numbers in the 7th row are 1, 6, 15, 20, 15, 6, 1, which are the coefficient coefficients of the binomial expansion of x plus y to the power 6. Observation 8. X plus y to the power cube equals to 1 x cube plus 3 x square y plus 3 xy square plus 1 y cube. 9th, x plus y to the power 5. So the expansion of x plus y to the power 5 is 1 x to the power 5 plus 5 x to the power 4 y plus 10 x to the power 3 y to the power 2 plus 10 x to the power 2 y to the power 3 plus 5 x to the power 1 and y to the power 4 plus 1 y to the power 5. So this is the expansion for x plus y to the power 5. Now expansion of x plus y to the power 6 is equal to 1 x to the power 6 plus 6 x to the power 5 y plus 15 x to the power 4 y to the power 2 plus 20 x to the power 3 y to the power 3 plus 15 x to the power 2 y to the power 4 plus 6 x to the power 1 and y to the power 5 plus 1 y to the power 5. So this is the expansion for x plus y to the power 6. Now x plus y to the power 8. So the expansion is 1 x to the power 8 plus 8 x to the power 7 y plus 28 x to the power 6 y to the power 2 plus 56 x to the power 5 y to the power 3 plus 70 x to the power 4 y to the power 4 plus 56 x to the power 3 y to the power 5 plus 28 x to the power 2 y to the power 6 plus 8 x to the power 1 and y to the power 7 plus 1 y to the power 8. So this is the expansion for x plus y to the power 8. see the expansion of x plus y to the power 10 equals to x to the power 10 plus 10 x to the power 9 y plus 45 x to the power 8 y to the power 2 plus 120 x to the power 7 y to the power 3 plus 210 x to the power 6 y to the power 4 plus 252 x to the power 5 y to the power 5 plus 210 x to the power 4 y to the power 6 plus 120 x to the power 3 y to the power 7 plus 45 x to the power 2 y to the power 8 plus 10 x y to the power 9 plus y to the power 10. So this is the expansion for x plus y to the power 10. So using Pascal's triangle, we can write the expansion of the expression a plus b to the power n, where n is a positive integer. So using Pascal's triangle, we can write expansion of any expression that is of the form a plus b to the power n, where n is a positive integer.